Okay, people, it's been a while since there's been a van cast. Let's get her done. We're gonna do something with plastics. How do they get around, and some of the chemical pollution involved with that. Okay, so some of the stuff is from National Geographic magazine. Nice little picture here. So first, we're gonna go down and deal with how they get around. By the way, nice little interesting piece of information down here, right? Every year, you inhale or ingest at least 120,000 microplastic particles between breathing. So what is that per day? Like 300 a day or so. Nice. Okay, so what might that do to us? First, how do microplastics get around? Oh, no, second. Okay, I'm just adding this. We looked at here. Remember, we went and saw an article, read an article about, and saw a video about seaweed blooms. This is in the Atlantic, sargassum seaweed having heavy metals in it. I think that's a newer discovery. That is serious. Okay. So they absorb, plastics also absorb metals, okay, and other chemicals such as endocrine disruptors, which affect the sexual characteristics of an organism. It's not uncommon to find fish, relatively uncommon, having tissue from both male and female tissue in the same fish, which is not supposed to happen. That's from endocrine disruptors, which do many, many different things, and plastics do have endocrine disruptors in them. Okay, so now to how does this stuff get all around? How do atmospheric and oceanic pollutants end up all over the place? One you're kind of familiar with. This guy here representing in the warm areas, there's a lot of warm, wet air convecting upward. And it has here, there's some deposition of air pollutants, but there's a lot going up. And then through all the various levels of air circulation, including the ones we looked at, those primary convection cells. There was 1, 2, 3 convection cells, which we don't have to worry about as much now. But basically, pollutants in the air get all around. They get in rain and everything. And then when you get to this drier, colder air up in the poles, there is more sinking air and there's more deposition of air pollutants. And it gets in the snow, the rain, it's in icebergs, it's just in everything. It's quite a bit up in the Arctic. And less so discovered so far in the Antarctic, because that is a continent down there. But this is the oceans, and it gets into the oceans, and it's warming quite a bit up there also. Anyway, I'm digressing too much. So that's one way, air pollutants all around. And the big sources for the pollutants, and especially mercury and metals, are industry, most especially using coal to produce electricity. And we've been doing that a long time, and we're now kind of paying the price on that. We got to pay our bill on that one. And then also transportation, cars, ships, trucks, planes, combusting a lot of material, and some of it has metals in it, among other things. Okay, so that's air pollutants. It simply goes all around the world. And then oceanic currents, which are less well known, obviously common sense. On the surface, winds blow ocean currents all around. There's a general prevailing current in this direction, right? That's the opposite of the spin of our Earth. So it just kind of on the current, the winds go that way, and it pushes the ocean currents. And then there's deep water currents. The two primary power areas with dropping huge amounts of colder, saltier seawater are there and there. So those are kind of the pump. Those 2 points are a big part of the pump, pushing this very slow moving oceanic current. Can take many centuries. I've seen different numbers, 500 years, 1,000 years. I've seen different numbers. So it's slow moving. This is very simplistic. It's very, very poorly understood. and there's currents all over the place. But this is this general movement indicate what's going on with these slow, called thermohaline. Thermo is temperature, haline is salt. So we have colder, saltier water here sinking, and here also colder, saltier water sinking over here also. So then, as well as these falling areas, these two main falling areas here and here, we have uplifting. We have the upwelling, the rising deep sea waters from this thermohaline current, and they have a lot of nutrients in them, actually, and they're quite important for areas that have a high productivity, because this nutrient-rich water from the deep ocean floor. Out here, California, this whole area has some important fisheries, and very famous is actually over here, also below North America. So we'll go around the map to over here. Peru, Chile have a very super important for the whole world fisheries here. They catch a lot of stuff, a lot of sardines in particular. So that's from this upwelling. So there are effects that I can demonstrate here. Okay, so one is the upwelling and the high productivity. So I just mentioned the Georges Banks is another area we looked at with the Atlantic cod out here off of eastern Canada, northeastern U.S. Those have historically very productive from an upwelling of these deep ocean currents. I mentioned Peru, and I should add Chile. And then also off of California, this area over here, very big issues with fisheries and actually climate change having an effect. So shifts of important fisheries due to warmer water, could be winds involved also, have really affected communities where their fishery has kind of drifted off, moved northward. Okay, this has happened off of eastern Canada and northeastern U.S. Some of these fisheries have moved north and just moving too far for some of the captains that did commercial fishing to use anymore. Also, California, this has happened also, some issues, and of course many other places, but I haven't had time to research those. And then our red tide is also affected. Here we are. So there's an offshoot depending on what map you see, but there's part of this current goes through on the seafloor in the Gulf of Mexico and also the Caribbean Sea here, and it goes around Florida and up. So us on the southwest coast, if there is a particularly stronger upwelling, not particularly, but just if there's if there's upwelling of any consequence, we will have less red tide organisms. So the plankton is called dinoflagellates. So they're mostly primary consumers of algae, primary producers. So if there's more upwelling here, then there will be less red tide. If there's less upwelling in the southwest area, off the coast of Florida, there will be more red tide issues, assuming the winds, there are westerly winds blowing the wind from the west to the east to our coast. Okay, I'm already, oh my God, 8 minutes. That's insane. Okay, so plastics. So plastics are not only at all on the top floating, they're found throughout the water column at all depths. So that's important to know. Here's a really charming picture of a seahorse and a Q-tip. We do have an endangered pygmy seahorse in Tampa Bay. You guys didn't know that. Okay, also rivers. So most ocean plastics do come from rivers, and most of them are microplastic clothing fibers, which could be reduced, but manufacturers have not yet what's the word I'm looking for? they haven't been persuaded enough to not do that. And then most of these plastics from this come from 10 rivers in Asia and Africa, so that would be possibly manageable. There's a lovely picture. Okay, here's a wonderful graphic from National Geographic. One year here in this Henderson Island, they studied where the different plastics came from, and you'll see most of it. This isn't the entire graphic, but most of it are fragments that they found. Okay, and then here they have plastic pellets, which are used the basis to melt. They melt those to make plastic stuff. Okay, plastic strapping, that's like ropes, fishing stuff. And then interestingly, we have bottle caps here, which are more, and lids, and plastic bottles, which are less. So I have a theory as to why that might be. A guess. It's not a theory, a guess. So it has to do with stormwater drains and the journey from the street to the ocean. Okay, and on we go. These are different. It breaks up or break down, whatever you want to call it, plastics, and it gets to the level where birds, you find them in seabird stomachs, and actually now the microplastics in the stomachs of plankton, big issue. There we have bottling. Okay, bottling water requires 1,000 times more energy and resources to produce, okay, when you're including the bottle itself. Okay, also bottled water is less regulated than tap water, and plastics use metals and BPAs, which are an endocrine disruptor, and you always have to think about fetus development in pregnant women. That's always a huge issue, and child development. Okay, so is it worth the negative impacts? I personally don't drink bottled water as a habit. I use tap water. Okay, recycling. Okay, Germany is very advanced in regards to recycling. The government subsidizes recycling so that it's a profitable business. Previously, most recyclable plastics were sent to China or a local landfill, and China is no longer an option. Their government has decided to stop accepting most recyclable plastics. So the U.S. and most governments have done little to support recycling. Most of what we put in recycling bins ends up in landfills. I'm not particularly motivated to use my recycling bin because I know it's not going to be used for that. Here's some National Geographic examples. Okay, obvious. We have here some kind of a stork, I think, and obviously what's going on. Hyenas in garbage. And then this is a cap, some bottle cap, and some kind of a hermit crab, I guess. But it's on land, so some other kind of crab. Then, there we go. This is the top. We're finished. Okay, here we have bits of microplastics in a plankton, a Daphnia. Daphnia are primary consumers. So the chemicals that will go in primary producers, already they're going to have these chemical metals and other chemicals like endocrine disruptors. If they're not broken down, bacteria will break down stuff to make them less harmful in some cases. So here's a Daphnia, nice picture. Okay, so it eats a lot of algae, but it also is ingesting microplastics. So that results in weaker organisms due to reductions in reproduction, nutrition, the immune system. I should put the immune system, muscular energy for getting food or escaping predators or just moving, and more. If metals are in or on the plastic, because some of these chemicals stick to the bacteria film, biofilm they call it, around the plastics. So plastics are like sponges, chemical sponges. Then toxicity will be an issue. Metals are already an issue for the marine food web chain, and a general decline in population should result, thus having a significant effect on the ecosystem food web and ecosystem productivity. So that is a quick review of some major issues with plastics and the pollutants. How do they get around the world? And that is what we have.